How do coordinates change after a 90-degree rotation about the origin? When you rotate a point, x, y, 90 degrees counterclockwise about the origin, it transforms to the point, minus y, x. When you rotate a point, x, y, 90 degrees clockwise about the origin, it transforms to the point, y minus x. A shorter version of the two rules state that a 90-degree counterclockwise rotation about the origin turns x, y to minus y, x, whereas a 90-degree clockwise rotation about the origin turns x, y to y minus x. Let's see how this works with an example. Take the point A at 3, 2. What are the coordinates of point A after a 90-degree counterclockwise rotation about the origin? According to the rule, x, y turns to minus y, x. So, 3, 2 turns to minus 2, 3. Let's plot the rotated point here and label it B. But why does the rule work? Let's draw a rectangle which places the original point A in the top right corner. Now, rotate the rectangle. The rotated point B is placed in the top left corner of the rotated rectangle. Let's study the two rectangles in relation to the x and y axis. The horizontal side of the original rectangle runs along the positive x-axis and gives the x-coordinate of the original point A. After rotating, this side becomes the vertical side running along the positive y-axis in the rotated rectangle. It gives the y-coordinate of the rotated point B. Likewise, the vertical side of the original rectangle runs along the positive y-axis and gives the y-coordinate of the original point A. This side becomes the horizontal side running along the negative x-axis in the rotated rectangle. It gives the x-coordinate of the rotated point B. You've checked the rule for a 90 degrees counterclockwise rotation about the origin from the first to the second quadrant. You can do the same for a rotation from the second to the third quadrant. Minus 2, 3 moves to minus 3, minus 2. Then, from the third to the fourth quadrant, minus 3, minus 2 moves to 2, minus 3. And finally, from the fourth to the first quadrant, 2 minus 3 moves to 3, 2. The result will always be the same, x, y moves to minus y, x. Let's look at a final example, this time for a clockwise rotation. You are asked to rotate the line segment EF 90 degrees clockwise about the origin. Let's start with this point, labeled E, at minus 3, minus 4. The rule says x, y moves to y minus x. X is minus 3 and y is minus 4. The new x-coordinate is y, so you get minus 4. The new y-coordinate is minus x, which is minus minus 3. Remember your sign rules. A minus of a minus is a plus, so your new y-coordinate is 3. Let's place the rotated point, labeled E prime, here at minus 4, 3. Now for point F at 2 minus 2. In this case, x is 2 and y is minus 2. The new x-coordinate is y, so you get minus 2. The new y-coordinate is minus x, which is minus 2. Finally, let's place the rotated point, labeled F prime, here at minus 2, minus 2. The last thing to do is draw a line segment between the rotated points, like so. When you rotate a point, x, y, 90 degrees counterclockwise about the origin, it transforms to the point, minus y, x. When you rotate a point, x, y, 90 degrees clockwise about the origin, it transforms to the point, y minus x.